We'll be looking at quadratic equations with complex roots. To do this, we're going to review complex numbers, we're going to review the discriminant, and we're going to use the quadratic formula to solve quadratic equations. A complex number is one that is composed of a real and imaginary number. It's written in the form a plus bi, where a is the real number portion and bi represents the imaginary number portion. Now when we go to discriminants, the discriminant is the b squared minus 4ac portion of the quadratic formula. And the importance of the discriminant is that it helps determine whether the roots will have radicals or it will have complex roots. And if the value of b squared minus 4ac is less than 0, you know you have complex roots. So we have the equation x squared plus 6x plus 10 equal to 0, and we want to find out what type of roots it's going to have. So a is equal to 1, b equal to 6, and c equal to 10. Now we need to find the value of b squared minus 4ac. So that's going to give us 6 squared minus 4 times 1 times 10, which is 36 minus 40, which is going to give us negative 4. So because this is less than 0, we have complex roots. So let's look at how we're going to use the quadratic formula. First of all, we compare the quadratic equation with the standard, which is ax squared plus bx plus c equal to 0. We substitute the values of a, b, and c into the quadratic formula. X equal to negative b plus or minus square root of b squared minus 4ac all divided by 2a. And we solve for x, or the unknown variable. Let's put that to practice. The first step we're going to do is compare with ax squared plus bx plus c equal to 0, and we have a equal to 1, b equal to 6, and c equal to 11. So x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. So let's substitute negative 6 plus or minus square root of 6 squared minus 4 times 1 times 11 over 2 times 1, which is going to be negative 6 plus or minus square root of 36 minus 44 over 2, which is equal to negative 6 plus or minus square root of negative 8 divided by 2. So let's come over here and break up 8. We decompose that, divide by 2, we have 4, and 4 we divide by 2, and we get 2. So what this now means, we'll bring this back up here, this is equal to negative 6 plus or minus 2i square root of 2 over 2, which is going to be, we can divide each term by 2, so we have negative 3 plus or minus I square root of 2. So x is going to be equal to negative 3 plus I square root of 2 and negative 3 minus I square root of 2. So these are the roots of that quadratic equation. We start off the same way. ax squared plus bx plus c equal to 0. A equal to 1, B equal to 8, and C equal to 26. Now x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Now we substitute, we have negative 8 plus or minus square root of 8 squared minus 4 times 1 times 26 divided by 2 times 1, which is going to give us negative 8 plus or minus square root of 64 minus 104 over 2, which is going to be negative 8 plus or minus square root of negative 40 over 2. So we're going to come over here and break up 40. So we divide by 2 and we have 20. We divide by 2, we have 10. We divide by 2, we have 5. So this is going to be a group, and then this 2 times 5 is going to be under the square root sign. So let's bring this up here. So this is going to give us negative 8 plus or minus 2i square root of 10 divided by 2. Each of these terms can be divided by 2, so we have negative 4 plus or minus I square root of 10. So now we have x equal to negative 4 plus I square root of 10 and negative 4 minus I square root of 10. So that's the solution to the quadratic equation. We apply the same method. We have ax squared plus bx plus c equal to 0. So a equal to 1, b equal to 10, and c equal to 169. But we know that x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. So let's substitute. So x is equal to negative 10 plus or minus square root of 10 squared minus 4 times 1 times 169 divided by 2 times 1, which is equal to negative 10 plus or minus square root of 100 minus 4 times 169. When you put that in the calculator, you show your work, you should get 676 divided by 2, which is equal to negative 10 plus or minus square root of negative 576 divided by 2. So let's look at 576 right here. We divide by 2, we get 288. We divide by 2, we get 144. We divide by 2, we get 72. We divide by 2, we get 36. We divide by 2, we get 18. Divide by 2, we get 9. We divide by 3, we get 3. So I'm going to pair up in group of 2s. I'm going to pair them up. One pair here, another pair here, another pair here, and then another pair. So we have 2, 2, 2, 3. So 2 times 2, 4 times 2, 8 times 3, 24. So let's bring this back up here. This is going to give us negative 10 plus or minus plus or minus 24i divided by 2. So we divide each term by 2. We have negative 5 plus or minus 12i. So x is equal to negative 5 plus 12i and negative 5 minus 12i. Final example, let's compare ax squared plus bx plus c equal to 0. So here a equal to 9, b equal to 0, and c equal to 121. But x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. So when we substitute, x is equal to 0 plus or minus square root of 0 squared minus 4 times 1 times 121 divided by 2 times 9. So this is going to give us square root of negative 484. So 0 plus or minus square root of negative 484 divided by 18. So let's decompose 484. 484 divided by 2, we get 242. We decompose 242. Divide by 2, we get 121, and then 121 is decomposed to 11 times 11. So this is going to be, we have one pair here, and we have another pair here. So this is going to be 0 plus or minus square root of negative 484 over 18, which we're going to bring up here to give us 0 plus or minus 22i over 18. So we're going to have, we can divide both by 2 because they're even numbers. It's going to give us plus or minus 11i over 9. So x is equal to 11i over 9, or negative 11i over 9. So this is how we use the quadratic formula to derive complex roots of quadratic equations.